Hello, today we're going to be going over the earthquakes and volcanoes slideshow. This can help you with the standard ESS 2.4, .5, and .2. So these are all important because these all result from plate tectonics, which is the plate movement. And so I want you to really pay attention to this. You can use this as a review. It shouldn't take too long. And then hopefully it will give you a little bit of clarity. When we talk about seismic waves, we'll also be talking about the different types of faults that result at particular boundaries. And we remember those boundaries were convergent, divergent, and transform. So how does stress change the Earth's crust? Well, forces created by plate movement are examples of stress. And stress is any force that acts on the rock to change its shape or volume. If you think about yourself, if you've been under stress, and you can ask your parents about this, if you're under stress and everything, a lot of times you'll develop more wrinkles. Your blood pressure may go up. The changes will happen when you get under a stress situation. When we talk about stress as it relates to rocks, there are three kinds. And remember the three types of boundaries we have. We have the divergent, where things move apart, convergent, where the plates move together, and then the transform boundary. And so those relate directly to the three types of stress that we have that change Earth's crust. The first one we're going to talk about is tension. Now, when you think about tension, you're thinking about getting stretched, to a situation where, um, you're just feeling all kinds of pressure. And that's the same thing that happens if you are using a slingshot, for example, or stretching a rubber band. When you pull on it, you're putting it under stress. If you put enough stress, it would actually break. But if you can think about holding something and stretching it, you're going to find out that it's going to become very, very thin in the middle. When the more you stretch it, the more it's going to thin out in the middle. And that's the same thing that happens when rock gets stretched. When it's under that stress and is being stretched, it's going to get very, very thin in the middle. And when things are pulling apart, what kind of boundary is that? That is a divergent boundary. That's one that is moving apart. The opposite of that happens at a convergent boundary, is compression. This is when things are pressed. And anytime you press something, you're squeezing it, you're pushing it together. And you can do this until it can fold or break or pop up. But when things are pushed together and squeezed, that is called compression. And that happens at a convergent boundary. And then the third type that happens at a transform boundary is shearing. A rock is pushed in two opposite directions. And when that happens, when one slides and breaks apart, that is called shearing. And that's the side to side movement that happens at a transform boundary. When enough stress builds up in rock, the rock will break. This creates a fault. A normal fault, it's at an angle, so one block of rock sits over the fault, and this is called a hanging wall, and another block of rock lies under the fault. So in other words, when there is a crack, there's going to be one section that's going to lean over the other section. Obviously, the one that's on top is going to be called the hanging wall, and the one that's underneath is going to be called the foot wall. And over time, the hanging wall will slip downward. And this occurs at a divergent boundary. So we can think about that. I have a couple of blocks of wood, and I don't know if you'll be able to see them. But obviously, if you look at them, the one that's on the top is going to be the hanging wall, and the one on the bottom is our foot wall. And so we're going to talk about that in a minute. But you know that the normal thing for this to do, this is going to either slide up or it's going to slide down. And we're going to think about that in just a moment. Over time, that hanging wall will probably slip down. And if it slips down, think about where that's going to happen. If I pull my hands apart, let me get that adjusted. If I pull my hands apart, they're going to slide down. But if I push together, my hands together, then that's the opposite. That is the reverse of it. So my hanging wall goes up, that's reverse. If the hanging wall slips down, that is a normal fault. And if you think about it, it is normal for things that are hanging to go down. So that's one way that we can normally remember what is normal and what is not. If they're pulling apart, they're going to slide down. That happens at a divergent boundary. As I said, the reverse fault, the hanging wall moves upward. This is at a convergent boundary. And then the strike slip fault is a transform boundary fault, a transform fault. And I'll move my picture out of the way for just a second. This one, they slip past each other sideways with little up or down motion. So you could look at the same blocks, and if they're moving side to side, that is a strike slip fault. Remember, if they slide down, that's normal. If it pushes up, that's reverse. So what you have is a divergent boundary, convergent boundary, and then strike slip. But the strike slip fault always occurs at a transform boundary. Okay, once again, I'll move the picture. Okay, folds in Earth's crust occur when compressions shorten and thicken Earth's crust. If things are pushed together, they're going to get shorter and they're going to get thicker. So these folds are happening at a convergent boundary. It can be a few centimeters or hundreds of kilometers wide. A fold in a rock that bends upward is called an anticline. That's an arch that is called an anticline. And then if the fold in the rock bends it downward, that's going to be in a V shape. That is called a syncline, syncline. And there's really not an easy way to remember those. You pretty much just have to, that's one of those things you just have to learn and know. And you can think up some kind of a fun thing in your mind to help you remember those. But anticline and incline, you think about incline going up and an anticline. So just think about them that way, and perhaps it will help. But those folds in the rock that bend up are anticlines, and those that bend down are synclines. These form mountains. Uh, these form from the collision of two plates and create some of the largest mountain ranges. So when you think about a really, really big mountain that's been pressed way up there, that's an anticline. Whereas you find a big bend downward and going down into a valley in the V shape, that is a syncline. Next, we'll talk about fault block mountains. And these are where two plates are moving away from each other. If we can remember the stress where things are pulled away, that's called tension. And this creates many normal faults. So if you have the hanging walls fall down off each side, I'll go the opposite way, or if it's on this side and slides down, this is what creates something called a fault block mountain. And if you could see, you could actually walk up that. And when you go out, hopefully you go out hiking and exploring, sometimes you can find where layers of rock have slid down, and you may want to climb up those. That's called a fault block mountain, and those happen where the hanging wall slips down. Hanging things going down is normal, so this is a normal fault, and therefore it is at a divergent boundary. These same forces that raise mountains can create plateaus, and a plateau is a large area of flat land elevated high above sea level. Okay, this is going to finish the part one of earthquakes and volcanoes, and So I want you to just keep in mind the three types of stress are tension, compression, and shearing. And then think about the three types of faults associated with them. You have the normal fault, you have the reverse fault, where things push together, and you have the strike slip fault, which is a transform boundary. And these really, you need just to write them down. You can create some little matching cards that go with them and find little activities. But remember, when something is on top and it slides down, that's normal, but that's because they're pulling apart. And if they're pulling apart, that's tension, and that tension is a divergent boundary. Remember when the reverse fault, when the a reverse fault is when the hanging wall slips up. That's because they're being pressed together. That's called compression. That happens at a convergent boundary. And then when things just slide past each other, that is a transform boundary. Anyway, that finishes the PowerPoint review, earthquakes and volcanoes. Please join me for the second part, which is over the seismic waves, and that will directly correspond to one of the standards that is in there. If you want to refer to this standard, it is E8.ESS2.5. Thank you very much.